In this video, we're going to talk about how to change the subject of a formula. So let's say we have the equation y is equal to x plus 8. So right now, y is by itself on the left side of the equation. So it's currently the subject of the formula. How can we make the subject x? How can we rearrange the equation and get x by itself? So how can we solve for the variable x? What do you think we need to do? First, we need to subtract both sides by 8. Or you could just move the 8 to the other side. But if you want to show your work, you can do it like this. So right now we have y minus 8 is equal to x. So now that we have x by itself, we're done. So the answer is just x is equal to y minus 8. Now let's try another similar example, but a little bit different. So once again, make x the subject of the formula. Solve for x. Let's begin by adding x to both sides. So right now I have x plus y is equal to 3. Our next step is you can subtract both sides by y, or just move it from the left side to the right side. On the left side, it's positive y, but on the right side, it's going to be negative y. So this is going to be x is equal to 3 minus y. And so this is the answer for the second example. Now let's try another example. V is equal to IR. This is associated with Ohm's law. Voltage is equal to current multiplied by resistance. How can we solve for the current? How can we make I the subject in this equation? Go ahead and try this problem. In order to get I by itself, we need to divide both sides by R. R divided by R is 1. So thus we have the current, represented by this symbol I, is equal to the voltage divided by the resistance. So this is the answer for the third example. Here's another example. Density is the ratio of mass and volume. Go ahead and make V the subject of the formula. So what do you think is the first thing that we need to do for this problem? How can we get V by itself? We need to multiply both sides of the equation by V. V divided by V is 1. So we have density times volume is equal to the mass. Now to get V by itself, we need to divide both sides by D. So the volume is the mass divided by the density. So this right here is the answer. Let's say that y is equal to 2 over 5 times x. Go ahead and make x the subject of the formula. So what do you think we should do in this particular example? What I would recommend doing is multiplying both sides by the reciprocal of 2 over 5, which is 5 over 2. In this way, the 2's will cancel and the 5's will cancel. So the answer is x is equal to 5 over 2y, or you can write it as x is equal to 5y divided by 2. It's the same. Now let's talk about temperature. The Fahrenheit temperature is 9 over 5 times the Celsius temperature plus 32. Go ahead and make C the subject of the formula. Now what I would recommend doing is subtracting both sides by 32 initially. So we got F minus 32 is equal to 9 over 5 times the Celsius temperature. Now let's multiply both sides by the reciprocal of 9 over 5. So that's going to be 5 over 9. So we're going to have the Celsius temperature is 5 over 9 times the Fahrenheit temperature minus 32. So this is the answer. Here's another one. The kinetic energy of a moving object is equal to 1/2 times the mass of the moving object times the square of the speed of the moving object. So let's make v the subject of the formula. Go ahead and try it. So first I would try to get rid of the fraction. I would multiply both sides by 2. Let me just put a line to separate v. So 1/2 times 2 is 1. So right now we have 2 times the kinetic energy is equal to the mass times the square of the speed. The next thing is to separate m from v squared. So we need to divide both sides by m. So at this point, I'm going to reverse it. We have v squared is equal to 2ke divided by m. Now, how do we go from v squared to v? What do you think we need to do? We need to take the square root of v squared, which will give us v. So we need to take the square root of both sides. So the speed is going to be the square root of 2 times the kinetic energy divided by the mass. So this right here is the answer. Now, try this one. The acceleration of a particle is the change in velocity divided by the change in time, where Vf is the final velocity, Vo is the initial velocity, A is acceleration, T is time. So in this particular example, make the final velocity the subject of the formula. So first we're going to multiply both sides by t, just to get rid of the fraction. So AT is equal to Vf minus Vo. The last thing we need to do is add Vo to both sides. So Vo plus AT is equal to Vf. So this right here is the answer. Now let's try some harder examples. Let's say we have x minus b divided by 4 is equal to x minus a divided by 5. Go ahead and make x the subject of the formula. Now, whenever you have two fractions separated by an equal sign, what you want to do is you want to cross multiply. So this is going to be 4 times x minus a, and that is going to equal 5 times x minus b. So now that we have parentheses in this equation, we need to distribute. So 4 times x is 4x, and then it's going to be negative 4a, and that's going to equal 5 times x, and then 5 times negative b. Now we're trying to get x by itself, and we have it on both sides of the equation. So what we're going to do is we're going to subtract both sides by 4x. This will get rid of the x variable on the left, but we're going to have one on the right side. And then we're going to add 5b to both sides. Now we can't add 4a and 5b because they're not like terms. So I'm going to write it as 5b minus 4a. 5x minus 4x is 1x, which is simply x. So this right here is the answer. X is the difference between 5b and 4a. Now for those of you who have been watching my videos, if you like them, and if you haven't done so already, feel free to subscribe to this channel. Also, when you get a chance, you can check out this website. I'm going to post some links, and you can get access to a lot of my playlists like physics, chemistry, algebra. You can find all of that on this website, especially for those of you who might be studying for, let's say, a physics exam or a chemistry final exam. I'm going to post some links at this website where you can find help for those things. So let's get back to the video. Here's another challenge problem. Let's say that r is equal to 3x plus 4 over 5x minus 7. Go ahead and try that one. Now, one thing I would recommend doing is multiplying both sides by 5x minus 7. And on the left side, we're going to have r times 5x minus 7, and on the right side, 3x plus 4. Now, our next step is to distribute the r. So we're going to have r times 5x, that's 5rx, and then r times negative 7, which is negative 7r. Now, these two are not like terms. So in this case, to get x by itself, which I forgot to say that, so I'm going to say it now. We're trying to make x the subject of the formula. Before r was the subject of the formula, and the only other variable is x, so it's safe to say that we're trying to make x, or we're trying to solve it and get it by itself. But let's get back to this problem. Now, we can move 5rx to the right side, or we can move 3x to the left side. It really doesn't matter. But let's move 3x to the left side. So we're going to have 5rx minus 3x. Just remember, as you move it from the right side to the left side, the sign will change from positive to negative. And let's take a negative 7r, move it to the other side, where it's going to become positive 7r. So we have positive 7r plus 4. So now that we have these two x variables next to each other, what do you think we need to do next? In order to turn these two x variables into a single x variable, what we're going to do is we're going to factor the GCF, which is x. So taking out x, we're going to have 5r minus 3. Now our next step is to divide both sides by 5r minus 3. And now we're almost finished. So this is going to give us x is equal to 7r plus 4 divided by 5r minus 3. And that's how we can make x the subject of the formula in this particular example. It's a little bit harder than the other ones, but the key is to factor out x when you get all these variables on one side of the equation. In a circuit with two parallel resistors, you could use this equation to calculate the total resistance, also known as the equivalent resistance, represented by RT. So given this equation, let's make R1 the subject of the formula. So go ahead and rearrange this formula to solve for R1. Now, the first thing that I would recommend doing is taking this term, moving it to the other side. It's positive on the right side, but it will be negative on the left side. So we're going to have 1 over RT minus 1 over R2, and that's going to equal 1 over R1. Now, if you want to, you can just reverse the two equations. You can write 1 over R1 first. Now, what do you think our next step is? What should we do at this point? We can raise both sides to the negative 1 power. By the way, there's more than one way of solving this problem. 1 over R1 raised to the minus 1, basically you flip this fraction. It becomes 1 over R, which is just R, or R1. Now, this one you can't really flip it, so you just got to put it under 1. So we have this. Now, what we have is known as a complex fraction. So to simplify this fraction, we're going to multiply the top and the bottom by R2 and RT. So at the top, we have R2 times RT, and on the bottom, 1 over RT times this. The RT values will cancel, giving us R2. 1 over R2 times RT, R2 will cancel, giving us RT. So this right here is the answer. Now, I'm going to show you another way in which you can get the same answer. So let's go back to the original equation. And we're going to make R1 the subject again. Now, at this point, what you could do is multiply all three fractions by R1, R2, and RT. Once we multiply this fraction by these three things, RT will cancel, giving us R1 times R2. Now, this fraction times this, R1 will cancel, leaving behind R2 times RT. And then multiplying 1 over R2 times this, R2 will cancel, giving us R1 times RT. Now, we need to get R1 by itself. All of the terms with R1, we want to move it to one side of the equation. So R1, RT, I'm going to move it to the left side, where it's going to become negative. So I have R1, R2 minus R1, RT is equal to R2, RT. So now I have two R1s. I want to just get one of them, so I need to factor. If I factor out R1, I'm going to get R2 minus RT is equal to this. And then I could divide both sides by R2 minus RT, giving me the same answer. So the final answer for this problem is R1 is equal to R2 times RT divided by R2 minus RT. So those are the two main ways in which you can do this particular problem. Now let's add some square roots into the mix. So this is the formula for a satellite orbiting a planet. V represents the velocity or the speed of the satellite, just the magnitude only. The magnitude of velocity is speed. G is a constant, M is the mass of the planet, and R is basically the orbital radius. It's the distance between the satellite and the center of the planet. But in this particular problem, what we need to know is what we're solving for. So let's solve for M. Let's rearrange it to get M by itself. Now the first thing we should do is, what do you think we should do? What's the first step? What I would recommend doing is getting rid of the square root symbol. And to do that, you need to square both sides of the equation. So we're going to have V squared is equal to GM divided by R. Now the next step is to multiply both sides by R to get rid of the fraction. And so now we have GM is equal to R V squared. And as you can see, I reverse the equation, which you can do. Dividing both sides by G, we can isolate the variable M. So M is going to be R V squared divided by G. And that's it for this problem. Number 13. The period of a pendulum is 2 pi times the square root of L over G. Let's make a G the subject of the formula. Now, you can square both sides now, or you can square it later. It doesn't matter. What I'm going to do first is I'm going to divide both sides by 2 pi. So I have T divided by 2 pi is equal to the square root of L over G. So now at this point, I'm going to take the square of both sides. So I have T squared divided by 2 squared is 4, and then we need to square the pi as well. On the right side, we can get rid of the square root symbol. So it's just L over G. Now we're trying to get G by itself. So what do you recommend that we should do? We do have two fractions separated by an equal sign, so we can cross multiply. So let's go ahead and do that. So this is going to be G times T squared, and that's going to equal 4 pi squared times L. Next, let's divide both sides by T squared. So this will give us the answer. G, the gravitational acceleration, is equal to 4 pi squared divided by, times the length of the pendulum divided by the period of the pendulum. So that's the answer. Here's another one. The electric force between two charged particles is equal to a constant called K times Q1 and Q2, which represents the magnitude of the two charges. That is the magnitude of their electric charge, divided by R squared, where R is the distance between the center of those electric charges. In this example, let's make R the subject of the formula. So let's multiply both sides by r squared, just to get rid of the fraction. So now we have f times r squared is equal to k q1 q2. Next, let's divide both sides by f. So r squared is k q1 q2 divided by f. At this point, we could take the square root of both sides. So now we have the answer. R is equal to the square root of k times q1 times q2 divided by f. And that's it for this problem. So if you haven't done so already, don't forget to subscribe to this channel. Thanks again for watching.